title of this packet is A Deeper Look at Ionic and Covalent Bonding. In this packet, we will review some types of bonding and learn how to predict the type of bond that will form between two given atoms using both periodic trends and electronegativity data. To review, there are covalent bonds that involve shared electrons and ionic bonds that involve the transfer of electrons. Within covalent bonds, there are polar bonds that involve unequal sharing and nonpolar bonds that involve equal sharing. Take a moment to decide what kind of bond this is. Imagine that each guinea pig is an atom and the caret represents valence electrons. Is it ionic, polar covalent, or nonpolar covalent? You may be wondering what causes unequal sharing of electrons. Atoms have intrinsic physical properties that determine how strongly a particular atom wants to receive or give an electron. These properties are represented by the results of experimental measurements. We will look at electron affinity, ionization energy, and electronegativity. Electron affinity is the energy change that occurs when an element accepts an electron. In this figure, the electron affinities of selected elements are given in kilojoules per mole. These measurements were obtained from gas phase atoms. The noble gases have electron affinities less than 0. This is because they already have a stable electron configuration containing 8 valence electrons. They do not want more electrons. The halogens, however, have electron affinities of greater than 200 kilojoules per mole. They have 7 valence electrons and would very much like to receive an 8th electron so that they can be stable like the noble gases. Ionization energy is the energy that is required to remove an electron from an element. In this figure, the ionization energies of selected elements are given in megajoules per mole. These measurements were obtained from gas phase atoms. The elements on the left side of the periodic table have smaller ionization energies because it doesn't take much for them to give up an electron. The elements on the right-hand side of the table have a larger ionization energy because they do not want to lose electrons. You can predict the type of bond based on trends in the periodic table. Group 1 and 2 elements, except for hydrogen, tend to form ionic bonds with nonmetals. Nonmetals tend to form covalent bonds with each other and hydrogen. Oxygen, nitrogen, and fluorine tend to form polar covalent bonds. Electronegativity is the ability of an atom to attract electrons towards itself in a chemical bond. In this figure, the electronegativities of selected elements are given in Paulines. These values were calculated from the standard enthalpy changes that occur when a chemical bond is broken. The noble gases do not have an electronegativity because these elements do not form bonds. The larger the electronegativity, the easier it is for that element to draw electrons towards itself in a chemical bond. Nitrogen, oxygen, and fluorine all have a large electronegativity. Therefore, in a covalent bond, they tend to have unequal sharing, resulting in a polar covalent bond. You can use electronegativity data to predict bond type. First, look up the electronegativity of the two atoms involved in the bond. Then, find the difference in their electronegativities. The greater the difference is, the more ionic the bond will be. As a rule of thumb, if the difference is less than 0.4, you have a nonpolar covalent bond. If the difference is greater than 1.7, you have an ionic bond. Everything else in between is a polar covalent bond. Try to predict the type of bonds that will form for the following molecules.